Hi, everyone. Thanks for joining tonight. We're going to give it a few minutes for people to log on. In the meantime, I have a few poll questions for everyone. All right, so while people are still joining, feel free to answer these. So first question, have you ever attended one of Oregon Wild's webcasts before? I'll give folks a few seconds to answer that.
Say, I don't get to vote?
Can you not vote?
It says that the host and panelists can't vote. So.
Well, Liz, have you ever attended an Oregon Wild webcast before? Besides this one?
I have, yeah.
All right, maybe 5 more seconds to get your answers in. Okay, we have good mix, some who regularly attend, a few who occasionally attend, and 7 so far first timers. So welcome to Oregon Wild Webcasts. All right, I have a couple more for everyone. For those just joining, we'll start in a few minutes. I just have a couple poll questions that you can answer while we're waiting. Okay, next one is a fun one. Since we're talking about rivers today, what is your favorite Oregon river? Liz, you can answer if you like.
Oh, I mean, I don't know if I can. Like, how do you choose?
Right, that's why I have so many options on here. So I'll read them off for people. The Deschutes, Mackenzie, Rogue, John Day, Clackamas, Oahe, Grand Ronde, and other, because we have so many other amazing ones too.
And I noticed that the Molalla is not one of the choices.
Yeah, sorry, I should have changed it. I made this for a previous webcast a while ago. I should have added the Molalla.
No worries.
My favorite is the Metolius, which I also didn't put on here. Yeah, for those joining, take 30 seconds or so to answer this. What's your favorite Oregon river? And we'll get started in just a few more minutes. All right, I think responses are slowing down. So tonight, the Mackenzie takes the cake. Most 13 people, Mackenzie River is their favorite. But good representation, everyone. You know, we have a lot of amazing rivers here in Oregon. So, okay, I got one more question for you all, and then we'll get started. This one is actually a quiz. So how many miles of streams across Oregon would the River Democracy Act help protect? And if you've never heard of the River Democracy Act, you can just take a guess, but you will learn about it later tonight. So few options: over 100 miles, over 1,000 miles, over 2,000 miles, or over 3,000 miles. All right, 10 more seconds for that one. Okay. So good job to all of you who guessed 3,000, over 3,000. That is the correct answer. And again, I'll talk a little bit about the River Democracy Act later. So if you don't know about it, hopefully you'll learn some interesting stuff later. All right, well, we'll get started. So hello, everyone. Thank you for joining us tonight. My name is Sammy Godlove. I am the Central Oregon Field Associate for Oregon Wild, based here in our Bend office. For those who may not be familiar with Oregon Wild, we work to protect and restore Oregon's wildlife, wildlands, and waters. And you can learn more about us by visiting our website, oregonwild.org. So today, again, we are talking all about rivers in Oregon, and I'm very excited to introduce you all to our guest presenter, who is doing some incredible restoration work on rivers here in Oregon. But first, I want to acknowledge that these rivers and the lands that surround them in what we today call Oregon are on the ancestral lands of both federally recognized and unrecognized tribes. And as settlers and guests of this land, we recognize the diverse Native communities of our region today and offer our respect and gratitude for their stewardship of these waters and lands throughout their generations. These tribal people were the original stewards of these lands since time immemorial and still steward these places today. And fortunately, as a result of tribal leadership and advocacy, we're starting to see some rivers be restored across the Pacific Northwest. A great example is rivers like the Klamath here in Oregon, where the world's largest dam removal is currently taking place. Makes me very happy every time I say that. Okay, so I just have a few housekeeping items to go over, and then I'll hand it off to Liz, our presenter for tonight. So first, thank you to all who purchased a raffle ticket this evening. We will be raffling off a copy of our Oregon Ancient Forest Hiking Guide, which I have a copy of right here. And then also an Oregon Wildway t-shirt. So there'll be 2 winners. These raffle ticket purchases not only help us continue these Wild Wednesday presentations, but also help make our work that we do at Oregon Wild possible. And winners will be notified via email within the next couple of days. Next, a recording of this webcast will be sent out to everyone who registered and will also be posted on our website under the Wild blog section. And then lastly, we will have a few minutes for Q&A at the end. You can submit your questions using the little Q&A function on the screen. And please feel free to just submit those questions as they come up throughout the presentation. Okay, I hope you're also with me. I am now very pleased to introduce our presenter for this evening. Liz Perkin is a river ecologist and fish biologist with Native Fish Society, who is currently managing a long-term restoration project on the Molalla River in partnership with the Oregon Department of Fish and Wildlife, Bureau of Land Management, and Fruit Growers Supply Company. I got to visit the project with Liz last fall, and there's some amazing work going on there, and I'm very excited for you all to learn about it and learn a bit more about how we can restore some of our rivers in Oregon. With that, Liz, you can share your screen and take it away.
Okay. Does that look good to you, Sammy?
Yep, all good.
Okay, great. So thanks so much, everyone, for joining us tonight. It's great to have everyone here. I'm going to start off by, sorry, I get my controls correct here. So this is just like the outline of the talk here. I'll start by going over just some basics about river ecosystems, really quickly running through some of the different forms of degradation that have happened and are common in Oregon. And then the restoration work we're doing in the Molalla. And I'm also going to highlight a couple projects actually being worked on by other groups that are a little bit longer. They started earlier than us, and so they're already seeing some really great results. So just to give you kind of a little bit of background on river ecosystems and how we kind of like a natural river ecosystem to look. This is the Queets River in Washington State in Olympic National Park. This is actually the river where I did this. These are the sites where I did my master's research looking at riparian processes. And you can see just looking at this aerial view that there's a lot of different habitats in a small area. And so this river is often actually used as an example for what a river what we would like a river to look like in Western Oregon and Washington when we do restoration, because it has a lot of the natural processes still functioning. It's mostly protected still. And so there's lots of large wood there. The floodplain is intact. The river is connected to the floodplain. And so you see an amazing diversity of both in-stream habitats as well as riparian terrestrial habitats very close to one another. And that's actually really important for maintaining species diversity in these systems. I do want to really quickly acknowledge that these lands, it's not accidental that rivers look the way they do. And I think, we tend to look at a river like the Queets and say, oh, it's this pristine system. It's been untouched by humans, but actually, these systems have been actively managed by indigenous peoples for thousands of years. As Sammy mentioned, a lot of these indigenous tribes are leading watershed restoration projects currently. And so I just want to kind of bring that up so we have it in mind that any watershed that we go into, even when colonizers came, it wasn't some untouched, just completely pristine area. Those ecosystems have always been actively managed. So going back to this aerial view of the Queets, I just want to highlight some components here. So, sorry, if we look at this overhead, you can see it's a little bit hard to make out, but there's piles of large wood spread throughout this system. And when we started looking at kind of the original old school restoration type, was really to do just say like, okay, there's a really simplified channel here. We need to put some large wood in there. And it would be some cabled large wood, maybe 3 or 4 pieces in one or two little spots. And okay, that added some little diversity in that one spot. But it didn't really address bigger issues. And so what we're really starting to look more often now at river restoration is process-based restoration. So restoring processes that rivers need to recover and be self-sustaining ecosystems. And so if we look at the processes that are happening, a lot is related to that large wood and the relationship of the large wood to the riparian forest. So as the river moves across the floodplain, it's constantly undercutting the banks and then recruiting large trees into the channel. And what happens, you can see on this top photo here, this is from, looking above this kind of cartoon, the flow of water is denoted by these arrows. So water is coming down fast. As it hits this large wood racked there, then it scours out deep right in front of the wood, but then behind the wood, it slows down a lot. And as it slows down, it drops out finer and finer materials. So something to always keep in mind too, when we're doing restoration, is that water, when it has energy, it can do work, quite literally. And so water that is moving very fast down a steep slope can move very large materials like boulders and very large trees. As it slows down, those larger items will start to drop out. And the more it slows, the smaller the items will start to drop out. And so when it's at its very slowest, like behind this log jam here, it's going so slow that it's actually going to lose fines like silts. And those silts actually allow riparian forests to develop much faster than upland forests. And that's actually why you see very large trees in riparian forests compared to the uplands. And even though this river, the Queets River, it's moving all the time, the lifespan of the riparian forest in this floodplain is about 300 years before it gets recruited back into the river. You still get trees that are 6 feet, 7 feet, 8 feet in diameter. They grow really fast because of those fine materials that get dropped out. But you only get those fines dropping out if you have those areas of slower moving water. So it's really important to have a diversity of habitat types of faster moving water and slower moving water to provide these different functions and structure in the river system. And so when we look at those, the different areas of a river too, we can see that the role they play for providing different habitats for animals. And this is going to be pretty fish focused. I am more of a fish focused person, but this provides lots of different habitats for all sorts of different wildlife and different fish species as well. And so you see that there are certain areas that provide habitat that are ideal for spawning, right? So if you look at the tail of a pool, where the water starts to go down to the gravels, that's really where salmon like to spawn and make their redds, and that's often where you get these really good gravels deposited there as well. Whereas if you look at a faster moving shallow riffle, then that provides really great habitat for aquatic insects, for a lot of different aquatic insects that then provide a major food source, not just for salmon, but for birds, for bats, for all sorts of animals. And then you actually need this slower moving kind of slack water that's off the main channel for juveniles to be able to survive. So juveniles don't really handle fast moving water very well. They need those slower waters. They actually need water that's a little bit warmer too, in order to grow faster. So if you notice when you're walking next to a river, you'll actually often find salmon fry really right next to the bank of a river. And part of that is because that's often really warm, productive water. And so it allows them to grow really quickly. It also helps protect them from predators who are larger and can't necessarily move into those areas. So it's important to have all these variety of habitats. And what we see with rivers that have been degraded is that we lose that variety of habitats. So you end up with very simplified channels that have very low diversity in structure. And so I am going to move pretty quickly through these different disturbance types, but just to give people kind of an understanding of the kinds of disturbance that happen in different rivers across Oregon. So one of the big things that happened, the big disturbances that happened in rivers across Western Oregon, Washington, Northern California, was the use of splash dams in logging and early logging practices. So early on, there weren't roads or railways along rivers or into these deep forests. And so the easiest way to transport large logs downstream into these big cities where it could be shipped to mills for milling was to use the rivers. And so they would just roll the logs down into the river. They would build a splash dam, a kind of temporary structured dam, roll the logs down into the river. And then once they wanted to move the logs, they would blow up or otherwise remove the splash dam. And then that carried all of the logged wood, but it also carried all of the wood that was naturally there as well. Or otherwise, they might also remove the large wood to make it easier. The art was already in the river to make it easier to get the felled wood downstream. And so that basically, it kind of scoured the channel. It often simplified the channel, and it eliminated the natural large wood stores. And so that was a disturbance that happened really early in a lot of Western Oregon rivers. Another disturbance is overgrazing. And this tends to be a bigger issue on the east side rivers, but you do occasionally see it on west side rivers too. So if cattle, horses, other ungulates aren't fenced off from riparian areas, the food is often really good there. And so they will often want to stand there and graze there. It provides easy access to water in the river. And so you can see the damage then when you have grazers removing the vegetation in the riparian area, the banks tend to fail and the river tends to get incised. As you can see here, this is actually a photo from the Molalla River. And so that's an issue that happens throughout really the Western US. Another thing that you see this is a little bit less common, but there's also mine tailings. And this is a photo from Google Earth looking just southeast of Sumter. in far eastern Oregon. And so there's an area that was well known for gold mining. And so there's a creek that's running through here, kind of the middle of this photo. And then all around it are these mine tailings. And so they would use a dredger to dredge up the bottom. And as a result, this channel has then become simplified and is also very confined. It can't move around. It's not connected to its floodplain anymore. And so this photo from the Oregon Historical Society really shows what that looks like on the ground. If you've ever been to Sumter, you know that area is really kind of wretched looking for the stream ecosystem. An additional downside of these tailings is that you not only have they confined the streams, there's the physical problems, but there's also often chemical problems that result from these tailings. There might be other minerals or elements that can be toxic to aquatic organisms that are leaching out then as well. Dams are another concern. And so this is mostly because they trap sediment behind them. And then you basically have sediment-starved rivers downstream of dams. And so just like I was saying that rivers can do work when they have energy, you have rivers coming out of dams that are actually still usually quite high energy, and they're not doing work, they're not moving sediment. And so they usually really erode downstream quite deeply and simplify the channel there as well. There's other issues with dams as far as altering thermal regimes as well. And so that's another major disturbance that happens in Oregon streams. Eventually, if you work in rivers in Oregon and do anything with restoration, you will hear that, well, you know, the flood of 1964 happened, and then the Army Corps came in and built berms or levees along the river because people got really afraid of flooding. And, you know, with good reason. The flood of 1964 was devastating. This is a photo of the steel bridge in Portland. And so obviously this is very severe. People did die during that flood. And it's interesting too. So when you actually go to look at what those levees, it's hard to necessarily identify them. You almost don't know, you don't know that a levee is there unless you know that one is there. Because they really just kind of bulldoze material, build up the banks, but they're usually all vegetated and grown over. And so it's not super obvious to the uninitiated that that's actually a levee or berm that's constraining the river and simplifying it. And I didn't have because of the overgrowth, I couldn't find a great photo to use of rivers in Oregon that have this, but I did find one on a river I worked in Alberta previously that had the same sort of built up berm. This is in a kind of some semi-urban area, suburban area, where they did the same thing for flood control, built up the banks and simplified the channel to prevent it flooding. And then we also have urbanization. And so what happens when you have a lot of impervious surface, so things like pavement, you have a lot of runoff moving very quickly into streams. You get really peaks, what we call flashy hydrographs. So you have a lot of water moving into a system all at once. Whereas in a natural system that doesn't have a lot of impervious surface, that rainwater goes into the ground and is stored in groundwater and slowly released into the creek. And you end up with very high peaks and actually more intense flooding as a result. And you can see the effects in this photo of that very flashy sort of hydrograph with high flows coming in. It ends up eroding banks and digging down deep. Now, this is a stream in Maryland that I worked near. But you also see the same pattern across Oregon as well. And so basically what this all comes down to, really all these disturbances at their core do the same sort of thing. And that is they create a new stable state. So a lot of times in habitat restoration, often the goal is really to just protect a habitat and let nature take over and regenerate and kind of take care of itself. And a lot of times you can do that, and it works, and it will, processes will start to reform. But when you have this sort of very simplified channel that's been separated from its floodplain, it then actually is a self-reinforcing system. So now you have all of this energy in a simplified system, and what happens when it can't move into its floodplain, when you get a flood, is that it will actually just keep digging down deeper and deeper, and will actually just reinforce then that channelization and the separation from the floodplain. And so in order to actually restore the processes, restore those habitats, it does sometimes actually take a pretty strong jarring shock to the system to get it back to a more functional state. And so now I wanted to talk about some of the restoration techniques we're doing, and go back to what I was saying earlier about that shift from this earlier idea of really just looking at individual sort of like, okay, we're going to put, maybe one little log jam here, one little log jam here, and, hope that that's going to improve spawning habitat or rearing habitat. People are really shifting away from that model and moving really towards a more integrated, as I said, process-based watershed scale restoration model. And so what exactly does that mean? To think of a watershed scale or process-based, and really you realize that you need to start at the top of a watershed and move your way down. If I try to put a few large wood jams down here, like around the town of Malala, when you have all this altered and potentially damaged watershed above it, it's just going to be washed out, because you're still going to have that high energy all above those jams that can then move them, damage them. They won't hold up, and you haven't restored the processes. But if you start up at the top of the watershed and you think, okay, so the best thing here might not necessarily be engineered jams. It might be replanting the riparian habitat. It might be just putting in a lot of pieces of wood. Then that will start to restore those processes higher up in the watershed. And then you can work your way down and start to really restore those processes throughout the watershed, right? So you're retaining sediment, you're holding things back, you're slowing water down, starting at the top of the watershed and then moving downstream. And so that's the model that we took. And as devastating as the fires of 2020 were, they also provided some interesting opportunities for a lot of watershed groups, and that fortunately the Oregon State Legislature saw the need for investing in watershed restoration following those fires, made quite a bit of money available for that purpose. And so our partners, Oregon Department of Fish and Wildlife, U.S. Bureau of Land Management, and then Fruit Grower Supply Company, which has been a great private land partner. We all got together and saw, okay, this is a great way to kind of kick off this watershed scale restoration, to think big and think about how can we really start to phase in projects that will really help the functioning of the ecosystem and hopefully bring back ESA listed spring chinook and winter steelhead in the basin. So these are locations of projects that we have. Some are funded by the fire recovery funds through Oregon Watershed Enhancement Board. Some are funded through Bureau of Land Management funds. But we still are planning on basically starting at the top of the watershed, moving down. So we have in phase 1 and 2, we have very steep slopes and spawning gravels that we want to help kind of shore up and help hold back those spawning gravels. And then further down in the watershed, we really want to connect the river back to its floodplain. So we can, again, kind of get more of the large wood coming in naturally to the channel, and hopefully also then eventually get larger trees growing in the riparian area again. And then previously we've done some work in thermal refuge protection, and Molalla River Watch, the watershed council in the basin, has also kind of taken that on, and they're doing more of that down further in the watershed. So phase one, we did last year, we completed this. So we worked with Columbia Helicopters to put about 500 pieces or so of wood into Copper Creek, which is a major tributary of the very upper Molalla River watershed. And this wasn't really engineered. It really was groups of people who have spent a lot of time in rivers, are very familiar with what, kind of natural large wood looks like in these complex systems. We were down in the creek and working with the crew from Columbia and just saying, okay, we need this many pieces of wood with root wads to go here and the tops to go here. And it was really amazing to work with Columbia and to see how accurate they are, and that they're just putting out pieces of flagging for the helicopter pilot, and sometimes the pilot was so good that they actually got the flagging trapped underneath the wood, and they'd have to get new pieces of flagging because it was just exactly on top of that flag. So this is kind of what that work looked like on the ground. You can see how these aren't engineered jams, but we're kind of looking to stack up those pieces of wood in a way so that you can see the steep slopes here on the side too, that burned and then went through salvage logging, and so are potentially prone to landslides. So the idea really with this project is that these jams then help slow down the water, capture any sediments that might be moving through the system, and but then also potentially spawning gravel as well. And then in that process, they're also then creating areas that are really good for juvenile steelhead and Chinook to rear in as well. And you can see that even though this is a pretty narrow creek, even in this pretty narrow creek, you actually have some what I would call incipient floodplain here off to the side. And so we also, whenever possible, we're looking to put the wood in places to reactivate those kind of little floodplain areas as well, and encourage more tree growth in there. And just to give you an example of how things have changed very quickly. So we did this almost exactly a year ago. The wood was placed in June of last year. And so this is a photo that I took of one of the wood placement areas before it was done in, I think, fall of 2022. And you can see, again, really simple channel. Everything kind of looks the same. There isn't a lot of diversity of habitat here. There's no pools really present. Obviously, this is during a low flow time. And then I took a photo during our replanting earlier this year. So this is in February. It's not quite, it's at the same place, but the angle of the photo isn't quite the same. So I took the previous photo from kind of where the person in the yellow pants is standing, looking upstream. But you can see already now we've gotten actually quite deep pools forming. So we've got great cover for juvenile fish to go under with all this large wood. We also have a diversity now of substrate types, right? So it's not just that very, very large cobble and boulders. We now have some fines mixed in. We've got gravels. So we actually have some material that's suitable for spawning. We still have plenty of places where you have some of that bigger gravel and cobble. So it's good for aquatic insects and spawning. So this next summer, we're looking at actually putting in some engineered log jams a little bit further down in the main stem Molalla. And this is a reach where it's about 1 mile long, and there should actually be really good spawning habitat for Chinook in this area. But because the river is just cranking through there and there's really nothing to slow it down, it is a very simplified habitat. The water just goes through, it takes out all the spawning gravel. I've done a spawning survey for spring Chinook in exactly this reach. And in the entire roughly 1 mile reach, there was one area of maybe 6 feet by 6 feet that had suitable spawning gravel present. And so the idea with these log jams that we're putting in here is to slow down the water and capture, retain some of those spawning gravels. We're also going to be reconnecting a little bit of a side channel here. You can kind of see in this drawing off to the bottom of this drawing. And that will then create more habitat again for rearing of juvenile spring Chinook, and create some calmer areas and allow some places for material to deposit. And again, for that riparian forest to benefit from floods more better. And so this is what the area looks like now. So again, very simple channel, large cobble and boulder is basically the only substrate there. And so we're looking to, you know, add some more structure to this, create areas where the water is going slow, but still have areas where the water is going fast as well. And hopefully get some more water into that floodplain off to the right-hand side that you see there as well. Just to give you an idea of the sorts of jams that will be built, this is kind of an example of one from one of the engineers, the hydrologist who's working with us on this design. And so this is the sort of structure we're working on. We use trees from the area and basically jam them into the ground and use boulders and things to help provide ballast as well and help stabilize it. So we're not using cable, we're not tying things anymore, but really trying to mimic the sorts of jams that would naturally occur in these places. And then I do want to give a shout out to projects in other areas. Since we're just getting started in the Molalla, you know, it's really exciting. It's great. It's great to see that we're already seeing some positive effects from that, just in that kind of first view post restoration. But I think it's really exciting, really exciting to look at some of the projects done by other groups across Oregon to get us a better idea of what we could maybe expect and hope for in the Molalla and other basins where restoration is maybe just starting, like the Klamath, for instance, with the dams coming down. So for those who don't know, this is an overhead of the Finn Rock Reach, where Mackenzie River Trust has been active. And this is also then restoration in the South Fork Mackenzie. This has been done by the Mackenzie Watershed Council. And I really love this photo because, you know, it shows again, just like in the Queets, right? We have a lot of diverse habitats really close to one another. So you've got places that are really great, suitable spawning habitat. We've got places for macroinvertebrates to thrive and survive. And then we also have more quiet, calmer backwaters that are a little warmer, where the juvenile fish can really do well, stay out of areas, stay away from predators, but also grow really quickly. And so, yeah, it's great to see these sorts of places. And now this is actually, hopefully we've moved from that previous stable state where it was disturbed, simplified, reinforcing a simplified channel that was getting deeper and deeper and more in size, to now moving to a self-reinforcing environment that's much more complex, that's where these processes are restored. So when you have these areas where there's slower moving water, then you're going to get riparian tree growth. You're going to get willows coming in, natural succession happen, and hopefully then larger trees moving into those areas that will then be undercut eventually and recruited back into the river. So you have these natural processes taking over and won't hopefully need then future human intervention anymore. And what's really exciting to see now is the use of these restored habitats by fish. And so these are each red dot represents a spring Chinook red in the project area. And so you can see this darker blue line that's there was the pre-project flow, so that you can see how limited it was, how narrow and channelized it was. Now that lighter blue is the restored area, so it's much larger. And you can see that there's a lot of reds already moving into those places. So that's really exciting to see that the fish are already making use of that habitat. And if in the Malala, for instance, we've identified that a lack of suitable spawning habitat is one of the biggest limitations to the spring Chinook population. And so if we can restore more spawning habitat, we can actually really start to increase the population size of those fish in the basin. Here's a similar project in the Sandy River Basin. So some of the partners we're working with directly with BLM, ODFW are actually working on these same projects in the Sandy Basin. And so they're already seeing positive effects here. So you've got this is an engineered wood jam across the stream, and there's actually the entrance to a reconnected side channel off there to the side. They're already seeing that habitat being used by fish spawning. So it's the same goal there is to try to retain spawning gravel. They're seeing exactly that, and they're seeing fish use that habitat to spawn in. And in fact, so some of you might be familiar with the fact that the Sandy River used to have a dam on it, the Marmot Dam, that was a blockage to fish passage. We're now seeing, since the removal of that dam and with habitat restoration that's been taken on over the years since then, that the sandy winter steelhead abundance, and even more impressive, really, the sandy spring Chinook populations have responded really well and are actually doing impressively well. And so I think it's so encouraging to see things like this, because it can be really hard sometimes working in native wild fish conservation, particularly salmonid conservation. There's a lot of doom and gloom and negativity that it can be really easy to get into this negative spiral. But we see actually these restored areas, you take dams out, you restore the habitat, you prevent hatchery fish from spawning with wild fish, and suddenly you see wild fish responding. And I think what gives me even more hope is that this is going against the trends that we've seen in those populations in larger areas. So spring Chinook in general are not doing super well. And so then the fact that these springers in the Sandy are kind of going against that bigger trend gives me hope that doing this habitat work is actually a way to drive their populations up, even in the face of climate change. So I need to acknowledge all the people who play a role in this. Obviously, when you're doing large scale restoration like this is not a single person who does this. This is the work of many, many people. So I want to shout out to all the people who have contributed. Hopefully I included everyone. I might have missed someone. But it's been amazing to work with all these people who really want to come together and restore salmon, restore processes, restore habitats. And like I said, not just salmon, but also other wildlife that benefit from this as well. And so I'm happy to take questions, but I know I think that Sammy has some things to say about the River Democracy Act too. So
yeah, I'll before we get to Q&A, I'll talk for a few minutes about the River Democracy Act. And Liz, can you stop sharing your screen? I'm going to share mine. But while I'm presenting, if you still have questions and you haven't submitted them yet, please feel free to submit those. We have quite a few already, but still time to get yours in. Okay. All right, so I'm going to talk to you all about a big campaign that Oregon Wild is working on right now to protect rivers in all corners of the state. This is the River Democracy Act. So we heard from Liz about the importance of restoring our impaired rivers and all the great work that's being done on that right now, like on the Malala to do that. But of course, we need to do more of it. And then at the same time, we also need to be protecting our rivers on the front end so they don't become degraded in the first place. And that's one thing the River Democracy Act can help accomplish. So before I get too much into it, I first want to mention this report from 2022 that really emphasizes this need to protect and restore rivers in Oregon. So this report was by the Environmental Integrity Project. And if you look at the highlighted sentence there, they found that Oregon has the most miles of impaired rivers of any streams of any state in the US. And impaired means that the streams don't meet water quality standards for things like drinking water, fish consumption, recreation, like swimming in the streams, or to sustain aquatic life. So this is kind of a shocking statistic and just shows that, you know, many of our rivers are in dire need of help right now. So I'll move on. This is a map of all the streams in the River Democracy Act. So this bill was first introduced by Senator Ron Wyden in 2021, and it would add over 3,200 miles of rivers and streams across Oregon to the National Wild and Scenic River System. So all these bright neon green lines that you're seeing on the map, these are all rivers and streams that would be designated as wild and scenic in this bill. And then in addition to protecting the streams themselves, the River Democracy Act would also protect a half-mile wide buffer on each side of each stream. So this in total amounts to about 2 million acres of public lands all across the state that would be protected through this bill. And then the dark blue lines on the map are streams that are already designated as wild and scenic around Oregon. So what is the Wild Scenic Rivers Act? How does it protect rivers? So the act was passed in 1968, and it really is the strongest form of river protection that we have nationally and our strongest river conservation tool. So this text on the slide here explains the purposes of the act. And Oregon's own Rogue River, which is pictured here, was one of the first 8 wild and scenic rivers that were designated as part of that original act in 1968. So today we have about 2,000 miles of protected wild and scenic rivers across Oregon. To give some perspective, that amounts to about 2% of our total river miles in Oregon. And again, the River Democracy Act would add an extra 3,200 miles to that total. So what protections does it provide? First, you can't dam a wild and scenic river, so it would protect the river and its ecosystem from any future dam construction. Again, there's that half-mile protected buffer on both sides of the stream. And then another thing it does is it designates and protects what are called outstandingly remarkable values, or often we call them ORVs. So when a wild and scenic river is designated, each one is given certain values for what makes the river special. And there can be more than one for each river. So these often include fish and wildlife habitat, geology, water quality, cultural uses, recreational, scenic, and others as well. And then once the ORVs are established for a stream, then any use that would harm or degrade one or more of the ORVs would be prohibited. So for example, if the river or stream provides clean drinking water to a community or is important salmon habitat, then anything that would harm the water quality and the drinking water or harm the habitat would not be allowed. And I didn't put on here, but another thing it does is it prevents any future mining claims. So once the river is designated, can't open up any new mining claims as well. So one very important ORV that many streams in Oregon provide is drinking water to local communities. So we at Oregon Wild did a study on where Oregonians get drinking water from and which drinking watersheds would receive additional protections from the River Democracy Act. So this map, all the blue shading on there is our drinking watersheds in Oregon. And then again, the blue lines are the River Democracy Act streams. The purple ones are the already wild and scenic streams. So in this study, we found that over 1.3 million Oregonians receive drinking water from watersheds that have River Democracy Act streams, and thus would see added protections from the bill. So this includes communities in Eugene, Clackamas County, Bend, Medford, others as well. I live in Bend, so I am one of those 1.3 million people, and I'm sure there's probably many of you out there tonight that are also included in that as well. Here's some photos of a few of the streams included in the bill. So, from the poll question that I asked at the very beginning of the webcast tonight, I know, many of you out there have a favorite river in Oregon. And this bill, includes many of those, and you can just, really see why these places are so special to a lot of us here in Oregon. Here's a few more photos. So really almost every single watershed in Oregon has at least one stream that is included in the River Democracy Act. And most watersheds have multiple streams in them. So this really is an opportunity unlike any we've ever had to protect this many rivers and streams all across the state at one time. Okay, and then very quickly, I hope I've been able to convince you why this is historic and important. If you want to learn more about the River Democracy Act, the Wild and Scenic Rivers Act, how you can get involved to help get this bill passed, you can visit our website, which is on the screen there. So Wild and Scenic designation takes an act of Congress, which means that it's up to you all, it's up to me, it's up to all of us to tell our members of Congress that we want to see this bill passed, that we want to see these rivers protected for future generations and all who depend on them. So you can do that in many ways, emailing them, calling them, tweeting at them, sending letters, attending their town halls, writing letters to the editor are always great. If you do live in Oregon, we made it very easy for you. You can take out your phone right now, scan this QR code, and it'll send a pre-written message to both Senators Wyden and Merkley, encouraging them to pass this bill. So I'll leave that up for just a minute if anyone wants to scan that, and we can transition to Q&A. Let me organize our questions really quick. All right, Liz, are you ready?
Yes, I'm ready.
Okay, we had actually several questions about beavers. So I'm going to kind of ask, or I'll combine them a bit here. So first, what role might beavers serve in modern river restoration? And then, is there any evidence of beaver activity on the Molalla? If so, is that helping?
Yeah, it's a great question. I was anticipating that someone might ask about beaver restoration. Really excited to hear about that. So in Western Oregon, the rivers tend to be large enough and moving fast enough that beaver restoration doesn't necessarily play an early role. But it is something that we want to encourage once we've connected the floodplain, because their activities in the activated floodplain can help maintain a lot of the internal processes within the floodplain. But it's really hard for beaver to kind of get going. They tend to not actually build as many dams in Western Oregon rivers, except for in those floodplain areas where the water is already moving a little bit slower. So we do see beaver activity in the Molalla. We don't we want to encourage it, and we actually are on some of those the BLM properties that are a little bit further down where we want to really reconnect the floodplain. We are actively thinking about beaver and how we can help support them and create better habitat for them. It's always a little bit tricky getting beaver going because if beaver are already there and active, they can be kind of eating your willows before they really get established. And so it's in a way, it's kind of nice that we have a little bit of a head start on them in the upper watershed, that we haven't really seen signs of them there as much. And so we really made a push to plant a lot of willows in there. And so hopefully those will get established and kind of get going. And then we're hoping the beaver will actually move up and start to work in that upper part of the watershed too. Certainly on the east side of the Cascades, beaver play a super important role in a lot of stream restoration. And people might have heard of a thing called BDAs, beaver dam analogs. So sometimes the streams have been so incised and are so deep that there's no connection to the floodplain. And so the beaver can't really get started building a dam because there just aren't actually, there's no willow left because there's, the willow would actually need enough moisture to grow, and there's no riparian. They can't get their roots far enough down. And so by building these kind of beaver dam analogs, by using driving poles down into the channel and then kind of weaving willows and other materials between them, you can kind of basically mimic a beaver dam and help start to retain some of that sediment, build up the bed kind of back and reconnect the floodplain. And then generally what we see is that in those areas, if there's a beaver family nearby, then the population expands and they can grow into that area and take over. And so beaver are definitely a really important part of modern stream restoration. And most people I know who are working in restoration are definitely thinking about beaver when they're planning restoration.
Right. We also had a lot of questions about dams, so I'm going to combine a few of those. So in general, how can we protect and or restore rivers that are more, and rivers and fisheries that are more impacted by dams where fish, can't get past the dams? Examples like the Deschutes with the Pelton and Round Butte dams. So besides maybe, just getting rid of the dams,
Eventually,
what can we do?
yeah, eventually that's the goal, right? Because there's a number of watershed councils groups in the Deschutes Basin that have been doing amazing work restoring streams in the middle Deschutes, so above the dams. It's like Waichus Creek is a great example of a really great restoration project. I encourage people to look into that project on their own. I'm actually working with Trout Unlimited. Trout Unlimited is the lead organization on it, looking at restoring areas of Trout Creek. And we're approaching it from that same sort of like low tech and using beaver dam analogs and post-assisted log structures. So not having to use heavy equipment, basically, but process-based or restoration, where we're trying to, create a lot of heterogeneity in the environment, right? Where you have slower moving water, faster moving water, really trying to get water reconnected to the floodplain and also stored into the groundwater. That's really important in a place like the Deschutes in particular. And I know that this is happening in the Klamath and the upper Klamath that are areas that are going to be reconnected now with the dams coming out. A focus on in these places that are arid and get warm. You have often high flows in the spring when the snow melts, trying to basically store that water into the groundwater. And so then when the water starts to recede, goes down further in the summer, that it will just come in slowly from that groundwater store. And it comes in at the temperature it went into the groundwater at. So if you have snow melt, it comes in usually very, very cold. And so that's usually too a goal of using beaver dam analogs or bringing beaver populations back they serve exactly that purpose of kind of moving water into the groundwater.
Okay, next question. Where is the large wood coming from that's being placed in the streams and rivers?
That's a great question. And it's probably one of the most difficult things when you're doing this restoration. And, it's really interesting too, because coming from doing my master's in the Queets, where there's just like, there's so many huge trees, and you can't even possibly move trees that are that big with the equipment that we have. So we have to use the trees that are available. We usually try to find trees that are in the basin, so we don't have to haul them very far. Last year, we used trees from BLM land that had been burned in the fire. And so we tipped them over, and there's a local timber company that we used, logging company we used to do that. And we are going to be using trees that are out of the basin now. It's coming from like a seed orchard where they grow trees commercially. The trees are too big now for them to sell, and so they just want them off the property. But it's always kind of an issue doing restorations. Like, where are you going to get the trees from? Usually US Forest Service and the BLM are major partners in these restoration projects, and you get the trees from somewhere on those federal lands. So instead of, having it be logged for commercial purposes, we take trees out of a small area to use for restoration.
Great. And we'll do last question. How realistic or maybe how difficult is it to try and control main stem river flows if so much of the uplands don't have adequate cover to help retain runoff? So I'm kind of thinking those photos of the Malala that you showed where there was the fire and then a lot of salvage logging. So of course, probably a lot of landslides and runoff.
I mean, it's been surprising to me, being up in the Malala, and I was there a lot the past couple of winters, and I was surprised by how clear the water was and how few landslides there were in the basin. I mean, we expect there will be some landslides that just happens naturally too. But I think actually, using those, we probably will still want to add more wood still to those higher tributaries to help provide some more stability. But I think, like we saw already from one of those pictures, we're already seeing places that are holding material, they're holding that fine material, that are actually slowing down the water. So I think it is working. If you get a really big, like a 1964 flood, I can't promise anything in that sort of situation. But I think and the longer, the more years we get without a 1964 flood, for things to kind of get established and regrow, the more likely it is to hold if we do get one of those really severe floods. So fingers crossed, but I think we're in a pretty good position now. And, we'll see if we need to add some more wood later.
Okay, not a question, but I think a good closing comment. This is from Steven. He says, "Thank you for all you are doing. If fish could only speak, they too would say thanks." So thank you, Liz. From us who speak for the fish in our rivers, thanks for your work. Thanks for joining us tonight and presenting. And thank you, everyone in the audience, for joining us as well. Hope you learned something new, and hope we see you on a future Oregon Wild webcast.
Yep. Thank you so much.
All right. Take care, everyone. Have a good night.
Bye.